everyone. I'm going to quickly present my work where I looked, or my topics, it's indicated as intelligent traffic load prediction algorithm for the Internet of Things. So that is what I'm going to look into. So my university is Tshwane University of Technology. I'm here in South Africa. So over the past years, we have seen an increase in the number of network devices that join the network. So whereby Internet of Things was also developed to also assist in our daily lives, whereby it allows the integration of data, various sensors and objects that we can use to communicate with one another. So it has been recommended, or other researchers have been saying that in the next coming years, we are going to have a lot of humans which are going to be in communication with them different network devices. So we want to ensure that we allow or we allow companies to be able to predict the different types of loads that can be or that network users can generate in the network. So this is just one example of an Internet of Things whereby a lot of devices are directly communicating to humans, and also humans are using these network devices to perform their daily jobs. So as I continue, this is one of the example where we see where Internet of Things covers. It covers wearable devices, entertainment, sports, healthcare, industrial appliances or automobiles and homes, and many more other network devices that we can use to make our life easier. So the reason why I did a study on this, I wanted to ensure that I can gain more knowledge in the field of Internet of Things, and also to learn about different traffic load prediction algorithms. And it was a burning desire to ensure that I help many network users to have or express good, better quality of service, and also to ensure that there is a network or there is an improved network throughput performance in the network. So the problem statement reads as follows: due to the rapid increase in the sensing data and the need of a quick response within the Internet of Things distribution network, high-speed transmission and resource management have emerged as the major issues. Assigning appropriate channels within wireless Internet of Things distribution networks is a fundamental guarantee of high speed, and also for better research management. It was supposed to be resource management there. I made a mistake. You'll forgive me for that. So the statement further is as follows: that high traffic load dynamics, however, renders the traditional fixed channel assignment algorithm and resource management algorithm ineffective for the Internet of Things. In addition, existing network traffic load prediction algorithms used in the Internet of Things has a poor prediction accuracy, which is not good for real-time traffic. So we want to ensure, or the solution which I'm going to present to you is going to solve the identified problem. There are different authors that has also tried to solve this couple of problems. So however, I'm just going to quickly go and look at the gaps of those solutions. So our first author there, referenced as 2, they also propose a solution that can also predict the data. However, their solution has a poor accuracy, or poor prediction accuracy when it's predicting the data, especially for real-time traffic. And also, again, our second reference there, referenced as 3, they also presented the solution that can also predict different traffic using vehicles when people are traveling using different vehicles. However, their mechanism also had a problem when it comes to them prediction accuracy. So that's why the developed algorithm want to ensure that it predicts data well. Again, our reference 4 also had a prediction accuracy problem. Again, our reference 5 also had a prediction problem when it comes to the real data. So I'm going to show you how I designed the proposed algorithm. So I designed the proposed algorithm by integrating linear regression algorithm and artificial neural network in order to present or design the proposed algorithm, which is linear aggregation artificial neural network algorithm. So linear aggregation algorithm, it's a machine learning algorithm that allows us to map numeric inputs in order to have numeric output. So we use this in a way where we can, it uses a mechanism, or it uses a model that maps the relationship between more variables in the network. So it allows, or it can be applicable into the Internet of Things because of its dynamic nature. So we also have artificial neural network that which is a theoretical or a mathematical model that also helps to combine existing network, sorry, existing input in order to have an output. So whereby it uses three layers. We have an input layer, then we have a hidden layer. Then I made a mistake. It was supposed to be input, hidden layer, and output layer. Yeah, here's the output layer. So these are the three layers that artificial neural network uses when when mapping this data. So this is the algorithm which we design. We had inputs where we put data into the network. Then it was going to do the counting of the data. Then we had different batch hierarchy that we used when we're assigning different data into the network. So I had a couple of algorithms. So I had a couple of equations which I used. So we said while count it's not, when while count it's equal, it's less or equal to, then we repeat the model where it's going to count the number of data that are being processed in the network. This will allow the model in order to predict the future traffic values that each and every network device can use based on the historical data. So this is the algorithm which we design. So we use NS2 to do the configuration for the device, where we had 20 network devices connected to each other transmitting data. Thereafter, we ran the simulation, then we recorded the score or the prediction output that we got on this file named outer.tr. Then we used R programming to plot this data in order to have output. So I'm going to show you the output. So this is the output that we got. So this is the proposed algorithm when it was predicting. So this is the actual data. This is the prediction. So you can see here that the algorithm mainly performed well because in average, the performance was very, very good as compared to this algorithm, which we compared our algorithm with. You can see here that the actual data and the predicted data as compared to ours is very close to the actual data. So this allows um, companies to plan well for their data in the network when they are using Internet of Things. So in conclusion, in this paper, we presented the design of the proposed algorithm, which is LRANN algorithm to perform traffic load prediction in order to ensure better channel assignment, resource allocation, and network management and task planning, which resulted in high-speed transmission of real-time traffic. In this case, why we say it resulted in high transmission of real-time traffic, it's because you can allocate bandwidth correctly to specific network devices, because based on the historical data, you know that these algorithms are going, also these devices are going to transmit such data. So you allocate higher bandwidth to these specific devices so that they can transmit data at a higher speed. So in future, we are going to test this algorithm in more complex network system, and then we're also going to look at the security part of it. How can we protect this data when it's being transmitted? So I think that is the end of my presentation. Thank you. I'll take advice and questions.
Wonderful presentation, sir. Sir, did you do the implementation of the model, whatever you have done?
Yes, yes, using C++. Yes, yes.
So, like, The results, can you show me once again, sir? Like, can you go to
Yeah,
results
these are
part?
the
Yeah,
results.
yeah.
Yes.
So these implementation are with respect to ANN software, right? In Python.
Come again. I used NS2. NS2 uses C++.
NS2 and C++. Okay.
Yes, yes.
Okay, sir. Okay.
All right, thanks.
Yeah. Anyone would like to ask any questions? Session is open for questions. Anybody would like to ask any questions? Yeah, it was a wonderful presentation, sir. I have much more questions to ask. Let me just, as the time is like we have more presentation, I'll just ask questions